We are going to learn how to solve equations today. We kind of have two ways of doing this. We have kind of the old school PEMDAS backwards, throw it over the river way that Mr. Hummel taught you. And he may have taught you arrow diagrams as well, but I thought we would take a few seconds to review arrow diagrams today. I just find that kids make fewer mistakes when they use an arrow diagram. I don't really care what method you use, but I'm going to focus on arrow diagrams in this chapter. So our first equation is the area of a circle. So I have 100 equals pi r squared, and you're going to be solving for r. So when you do the arrow diagram, we are always going to start with whatever variable you're solving for. So I start with an r here on the left. There are two operations for you to deal with. You have the multiplication and the square. So we're going to put an arrow for each of those operations across the top here. What happened there? PEMDAS says you do your exponents before you multiply. So I put the square on the first arrow times pi on the second arrow. And this is where the kind of the PEMDAS backwards part kind of comes into play. I don't know what's wrong with that. So on the bottom half of the arrow diagram, we're going to wind up putting an arrow for all the opposite operations here. Just a minute. Okay, now I'm back. So we're going to pretend we know what we're going to start with. So we're going to start with some number, and I'm going to square that number and multiply by pi. And if I pick the right number at the beginning, I should wind up with 100 at the end. And of course, that's how we'll check it. So I'm going to use my opposite operations. So the opposite of multiplying by pi is dividing by pi. Okay, now it did that silly thing again. Just a minute. So the opposite of multiplying by pi is dividing by pi, and the opposite of squaring is square rooting. So I'm going to take 100 divided by pi on my calculator, which would be 31.8. And then I'm going to take the square root of 31.8, which would give me 5.6. So here I am on the calculator. I take 100 divided by pi, gives me that 31.8. I just wanted to show you the key sequence so you didn't have to, retype in 31.8. So then we're going to go Control square root, and I can just arrow up and recapture that 31.8. It'll paste it right down in there for me, and that'll give me that number. So you'll be able to kind of use that up arrow business to recapture some of those values. And you should always know if you got one of these questions right. So all I would have to do is take that 5.6, plug it back into the equation. Because we said if we start with the right number, 5.6, square it and multiply by pi, I should get 100 for an answer. So if I go back over here, start with pi times 5.6 squared, drum roll please, I got 100 for an answer. So that means 5.641 blah, blah, blah is the correct answer there. So here's the next example. You have the area of a trapezoid formula. So what happens if A is 20 and H is 6 and the first base is 5 and the second base is 2. So we start out by putting those numbers into the equation, and now we can build the arrow diagram. Well, what do I have for operations? I have some of this multiplication and some addition, and I have some parentheses. So PEMDAS forward says, hey, we're going to do what's in the parentheses first. So we, hold on a second. Okay, we start PEMDAS forward. So we have a plus 5, but it's in parentheses. Normally the adding and subtracting would come later, but since it's in the parentheses, you would start with that. So we do the work in the parentheses first. We put a plus 5 on the first arrow. We started with B2. We're going to pretend we know what we're starting with. And whatever that number turns out to be, if we add 5, multiply by 6, and multiply by a half, I should get 20 for an answer. So the way that the arrow diagram works is we reverse all those things back out. So instead of multiplying by a half, we divide by a half. Instead of multiplying by 6, we divide by 6. Instead of adding 5, we subtract 5. Well, 20 divided by a half, well, that winds up being the same. Dividing by a half is the same as multiplying by 2 over 1. So 20 divided by half is the same as 20 times 2 gives me 40. 40 divided by 6, 6.6 repeating. 6.6 repeating minus 5 gives me 1.6 repeating. So if I head over to the calculator, I should be able to double check that. So here I have it, a half times 6 times 5 plus 1.6 repeating. And drum roll please, when I get done, I should get 20. Well, okay, pretty close. If I would have recaptured that, I would have done a little bit better job, you know, because we started with 20 times 2, and it gave me that, and then divided by 6, and it gave me that, and then minus 5 gave me that. So if I went back and redid this and retyped it, so I went a half times 6 times 5 plus, and then I'm going to go back up and recapture that, okay, and enter. And now if I type it back in again, that gave me exactly 20. There are a couple of weird problems where the arrow diagram, you know, doesn't work like right off the top of your head. So we kind of have to treat these a little bit differently. What we would do with a question like this is we don't like that x on the bottom. So to get rid of dividing by x, I'm going to take both sides. I'm going to multiply by x. So I have to multiply both sides by x, and those are going to wind up canceling. So now I have 5 equals 6x. So now I built my arrow diagram with that. Ooh, I hope I didn't show all that before. All right. So it's only a one arrow because I have multiplication on the top. So whatever I start with, I'm going to multiply by 6. I should get 5. So divide by 6 is 0.83 repeating. Another weird question is when I have x's all over the place, I can't really solve for x because was it this x or is it that x? So this is where Mr. Hummel's little metaphor of throwing stuff over the river. Of course, if you're going to throw it, you pick up the lighter one. So we're going to throw the 2x over the river and get the x's together beforehand. And then I wind up with 3 equals 2x minus 5, and I make my arrow diagram from that. So here's that arrow diagram. We're going to multiply before we subtract, you know, PEMDAS, times 2. We start with our variable, and we're going to, whatever number that works out to be, we're going to multiply by 2, subtract 5, and we should get 3. So I'm going to reverse everything out. Opposite of subtraction is addition. Opposite of multiplication is division. So 3 plus 5 is 8. 8 divided by 2 is 4. And that should work out for you. Again, here's one of those other weird ones where I have x's all over the place. So my key here is going to be getting those x's together. So what I wound up doing was distributing this negative 3. So it winds up being negative 3 times positive x, so it's negative 3x. A negative 3 times a positive 4 is negative 12. Now I can get my x's together, and 2x minus 3x is negative x. Now I can build my arrow diagram. Now this one's a little bit weird in that it has that negative x there, and that is like a negative 1 times x. So when I build my arrow diagram, the first thing I'm going to have is times negative 1, because multiply before you subtract. So I start with my variable, multiply before you subtract, PEMDAS. And if I start with the right number, I should get 5 out. So I reverse my operations, go from a negative 12 to a positive 12. So 5 plus 12 is 17. Opposite of multiplying is dividing by negative 1. So positive 17 divided by negative 1 is negative 17. Good luck on your homework. Lesson Master 15B.